With Chapter 8 today. Chapter 8 we will discuss systems of linear equations. Now basically let's go ahead and take a look at what is a system of linear equations. We've talked about linear equations in Chapter 7. In this chapter we're talking about systems of linear equations and how to solve the system of linear equations. So your system of linear equations is basically where you have more than one linear equation, you have two or more, and they will have the same variables. So sometimes you will also hear them being called as linear systems. And as I said, the first thing we will do in this section particularly is talk about how to solve the system of linear equations. And the first method we will consider is graphing. Now for a system of linear equations, you can expect any examples of this form where you have the same variable x and y in both your equations. If you want to use the variables a and b, that's fine as long as all the equations in your system use the same variable. So you can have any of these forms to your linear equation. Now let's go ahead and talk about what a solution to the linear systems will look like. Now you can have, depending on what kind of a system you have, you can have an ordered pair as your solution to a given system. Now to understand these ordered pairs, you have to understand that since we are talking of these as a system, the ordered pairs that are solutions to a given linear system have to satisfy all the equations in that system. So if you have two equations, your solution should satisfy or make both the equations true at the same time, and only then can that ordered pair be considered a solution to your given system. So let's go ahead and take a look at an example here where I'm giving you an ordered pair and a system, and we're trying to decide if the ordered pair is a solution to the given system or not. So we have this ordered pair 4, 3, and we're trying to decide if 4, 3 will satisfy x plus 2y equals 10 and satisfy 3x plus 5y equals 3. So all you need to do is substitute your x and y values with the x and y coordinates from your point. We'll start with the first equation. You have x plus 2y equals 10. We'll substitute our x with 4, substitute the y with 3, and let's see if we end up with a true statement. So you have 4 plus 6, which gives you 10, and you can see that the solution 4, 3 will satisfy our first equation, x plus 2y equals 10. Now let's see if it satisfies 3x plus 5y equals 3. Again, substitute your x with 4, your y with the 3, and this will give you 12 plus 15 equals 3, and of course you can see this will add up to give you 27, and 27 does not equal 3, and you end up with a false statement. So we can basically conclude that since 4, 3 satisfies one equation but not the other one, this cannot be a solution to this system, and therefore we cannot use 4, 3 as our answer here. So 4, 3 is not a solution. And again, because it did not satisfy our second equation. Okay. Now let's say we take a look at another example just to be sure what your solution should look like. So in this example, we have -9 and -2 as our ordered pair, and our two equations are 2x minus 5y equals -8 and 3x plus 6y equals -39. We'll do the exact same thing we did in the last example. Let's see if -9, -2 satisfies our first equation. So we have 2 times -9 minus 5 times -2, and that equals -8, which will give me -18 plus 10, and -18 plus 10 gives you -8. So our ordered pair will satisfy the first equation. Let's try with the second one. And you have okay, so that will give me -27, -12, and two negative numbers, so that will add up to give me a -39. And as you can see, when I use this ordered pair for both my equations, I end up with a true statement with each one of these, and now I can conclude that since it satisfies both my equations, it can be a solution to my system. Okay? All right. So